Hi, I'm David, and in this fundamental module we're going to be looking at the accelerator pedal position sensor. Electronic throttle control is part of our modern vehicles and has brought us many benefits. One of those benefits has been fuel consumption. Our fuel consumption has been reduced quite dramatically by the introduction of the accelerator pedal position sensor and throttle control. This is because there's no longer a direct link between the accelerator pedal and the throttle butterfly. If the driver was to accelerate hard, that doesn't mean that the throttle butterfly is going to open 100%. It'll all depend on the torque request and the load of the vehicle. So that improves our fuel economy. Emissions is also a benefit we get from throttle control. Because we now don't have this direct link between the accelerator pedal and the throttle butterfly, it enables us to open the throttle butterfly at times when it would normally be closed. This allows for a leaner mixture and reduced fuel consumption. Traction control is another benefit. Regardless of the accelerator pedal position that the driver inputs, if we need better traction, the engine control module can now take over the throttle opening, thus stabilising the vehicle. Stability control will now be enhanced by the use of throttle control rather than just the brakes. This makes for a much more stable vehicle and a safer vehicle. And all this is achieved by one sensor, the accelerator pedal position sensor. It takes a mechanical force and turns it into an electric signal. That goes back to the engine control module, which now gives us the optimum setting of our throttle under all conditions. So let's go back to the workshop. What we see here is a complete electronic throttle control system. We're only going to be concentrating on the accelerator pedal position sensor. As we can see here, the sensor is a variable resistor. It has a ground on one side from the control module and 5 volts on the other side, again from the control module. Our signal wire comes from the wiper arm and goes back into the module to a pull-down circuit. If you're not familiar with pull-up and pull-down circuits, there's another fundamentals module that deals with these circuits, so have a look at that one. Moving back to the complete sensor, we can see that there are 2 variable resistors inside there, and they are both connected to pull-down circuits. We have 2 signals going into the control module. The module now interprets these signals as an accelerator pedal position. The module makes a comparison between these 2 signals. If it's within range, it accepts the signals. If it's not, it'll set a fault code or a DTC indicating that there's a problem with the sensor. The circuit we have here is the same as the one we just saw in the diagram. We have 2 separate pull-down circuits. We have a sensor. In this case, we have 2 variable resistors on the one shaft, just like a pedal position sensor would be. We have our battery positive, 5 volts. And that supplies via the blue wires our sensors with their 5 volt reference. We have a ground circuit that goes down to our low reference to our sensor and also supplies our pull down circuit. We have 2 pull down resistors and we have 2 monitored points. So I've got 2 multimeters here connected up to my monitored points and to ground. And we'll have a look and see what this sensor does. If we're looking at the voltage, both of them are reading 0. As I start to turn the potentiometer, you'll see that the voltage starts to rise. It's the same on both of them, and if I keep going all the way up, it'll go to close to 5 volts on both of them. This is very similar to what the early accelerator pedal position sensors were like. Both voltages were the same, and they went from a 0 to 5 volts. We've had a lot of changes since then. Some of them go from a low voltage to a high voltage, some of them go, and the second one will go from a low voltage to a middle voltage. And we also have ones that reverse. One goes from low to high and one goes from high to low. And that's quite easy to achieve. All we simply have to do is change 2 wires. And what I'm effectively doing is on one of my potentiometers, I'm changing over the battery and the ground. There's no need to change from a pull-up to a pull-down circuit. That won't make any difference at all. So if we have a look at the multimeters now, you'll see one of them's on 0 volts and the other one's on nearly 5 volts. As I turn the shaft this time, you'll see that one of them starts to decrease and the other one starts to increase in voltage. So why go to all this trouble? Well, if the voltages are the same on both signal wires, if both signal wires are short to ground, there's no way of telling whether there's a fault. But if the signal wires do something different, if those two signal wires ever get shorted together, the module will know straight away that there's a problem and it will set a code. So let's go off to the vehicle and have a look at how it works there. So we've had a look at the schematic and we've had a look at the circuit board to show you how they work. Now let's have a look at a vehicle. We've got two multimeters here and one of them is connected to APP1 and the other one is connected to APP2. We've got a scan tool and that's going to show us what the module interprets those two signals as. So what we'll do is we'll get Dixon to operate the accelerator pedal slowly and we'll watch what happens to the meters and the scan tool. So as he starts to operate it, you can see they're both increasing in voltage the same. And if we have a look at our scan tool, we can see that the interpretation of that is that the accelerator pedal is opening. As the voltage starts to drop, when the pedal is being released, the same thing, the interpretation here is now that it is going to be closed. So I'll get Dixon to open and close the throttle quickly. This time we can't see the results on the multimeters because they're a little bit too slow. They don't scan it quite quick enough. But on our scan tool here, you can quite easily see how it operates. A lot of modern vehicles now don't use potentiometers as their sensors. They use a non-contact sensor, which could be a Hall effect or it could be an inductive type sensor. We'll see more of those coming out because they last longer and they're far more reliable. As a matter of fact, the vehicle we're working on now has one of these new type of sensors. It's a Hall effect type sensor. But regardless of which type of sensor we have, whether it's potentiometer, Hall effect, inductive, they still give us the same sort of information. We still get two voltage readings coming out of the sensor, and that's interpreted into an accelerator pedal position opening. And here you can see the location of the accelerator pedal position sensor. And as you can see, it has a 6-wire connector. And that's our accelerator pedal position sensor. We've looked at a schematic, we've had a look at a circuit, and we've seen how it works on a vehicle. It's a relatively simple sensor. It converts a mechanical force into electrical signals, but it's a key component to our electronic throttle control, and that gives us many benefits on our modern vehicle. Regardless of what type it is, we get two electrical signals out of it that go to the ECM. The ECM then decides the best throttle opening for every situation. And contact type or non-contact type, the testing is always the same. And we'll have a look in another module at how to test the accelerator pedal position sensor. So that concludes our module, and always remember, training is the key to your success. Bye for now.